So what I want to get out of this class opener is the fact that when we graph a line, that line represents the infinite amount of answers that exist to the equation. Okay, all the solutions that exist, right? So jot that down somewhere on your class opener. When we graph a line, that line represents the infinite amount of answers that exist to this equation. So let me prove it to you. Let's go to one of these points on this line. If you go to this coordinate right here of 2, 1, well, the 2 is your x value, the 1's your y value. It will work. If you plug in the 2 right here and the 1 right there, it'll be a true statement. Let me show you. 1 equals 2 times 2 minus 3. It'll work, right? Because 2 times 2 is 4. 4 take away 3 is 1. And the equal sign is there, and the 1's right there. So yes, 1 equals 1. It works, right? Any point on this line, any coordinate on this line will be an answer that works for this this equation right here. Does that make sense? So it doesn't matter if I go to this coordinate, the coordinate 0, negative 3, or this coordinate 4, 5. I mean, x equals 4, y equals 5. This is a solution to this equation right here. So the line represents the infinite amount of answers that exist to an equation. Okay, the infinite amount of answers that exist to an equation. Let's move on to today's actual lesson. So don't copy this down, all right, guys? I just want to relate these words to the future math vocab words we're using. So when you guys think of the word system, what does that pop up in your head? System. More than one? Okay, more than one. How about this guy right here? You guys know what this is right here? System. Bose Lifestyle System, theater system. It's like one of the best surround sound systems there is. I will never own it because that's $4,000. Yeah. Just for that? Yeah, just for that. But it sounds amazing. I've seen this, I've heard this in San Diego. They have it at the mall. Oh wait, I'm getting off topic. Anyways, that's a system. How about, here's a sound system in a car, right? Okay. Now, what do you notice about these systems, or how about the nervous system? Or the PlayStation system, right? The PlayStation is not just the console, right? You need several things working together in order for you to be able to game, right? You need your console, you need your controllers, you need the game itself, right? You need the cables. So it's all these different things working together. Same thing with the nervous system, right? You have your mind, you have other parts of your body, your nerves. Any type of system has more than one thing working together, right? So let's keep that in mind. System, more than one thing working together, okay? Consistent. Let's say somebody's consistently bugging you. What does that mean? Over and over, every day, all the time, right? Doesn't fail, always, right? Consistent. Let's keep that in mind. Inconsistent, let's just skip that for now. Independent. How about this? If you are financially independent, what does that mean? You can take care of yourself. You could take care of yourself. You pay for your own food. You work. You get your own paycheck. Everything. You're independent. Nobody helps you out. As opposed to being financially dependent, that's like, yeah, like you guys students, right? Whatever you spend is probably from your money, your parents' money, right? So being dependent is kind of like they're carrying you. They're carrying your weight, kind of like piggybacking you, right? Independent, you're on your own. Dependent, it's like you depend on somebody, they're carrying your weight. Let's keep that in mind. Let's move on. So let's talk about the first vocab word, and you don't even have to write this down. System of equations is simply two or more equations working together, kind of like a stereo system or the PlayStation system. It's more than one thing working together. It's simply two or more equations working together. So a system of equations, you have two equations that are working together. So you could solve, so when we ask you to solve a system, like it'd be easy if I told you, give me an answer to this top one, right? What plus what is 4? Give me a solution to this top one. 2 plus 2 is 4. That's a solution to the top one. Or there's a different solution like maybe 1 and 3, right? Or maybe 4 and 0, right? So there's an infinite amount of answers. And this one right here there's also an infinite amount of answers. But when we say solve the system, we're talking about both equations working together. So you want one answer that works for both. All right, so check this out. Give me one answer for the top one. Top one. For the top one. Forget the bottom, just the top. 2 and 2. If I say 2 and 2 is my answer, it's not going to work down here. 2 times 2 is 4, minus 2 is 0, not negative 7. So the answer 2 and 2 did not work. So we need a different one. Let's find that one answer that works for both equations. There's 30-something of us here. We should be able to figure this out. What do we got to do? We want to find the answer that works for both. Now, if I just said, like, let me show you. If I just said, find the answer to that one. Oh, well, that one, the answer could be 2 and 2, right? Because 2 plus 2 is 4. Or it could have been 3 and 1, because 3 plus 1 is 4. But when I say find the answer to the system, when you look at both of them, remember, a system is both of them working together. You got to find that one answer that works for both. So obviously, 3 and 1 is not going to work because 2 times 3 is 6. 6 minus 1 is 5, not negative 7. So let's think about it right now. Let's take a couple of minutes and think what numbers would work for the x and for the y, but in both, to give us both true statements. Go for it. Take your time. So using mental math, guys, like what number plus what number gives you 4? Now you could even use negative numbers. That's a hint I'm giving you right there. If you use a negative number here, give me a negative number. Negative 1. What's negative 1 plus something? 5. So negative 1 and 5. So here's our first guess with my hint of using a negative number. Negative 1 plus 5, it really is 4. So it checks off on the top one. Let's try it on the bottom one. Negative 1 right here. That'll be 2 times negative 1. That's negative 2. Negative 2 minus the 5 for the y. That will give you negative 7. Right? Okay, so we got very lucky, especially I gave you a hint. Right? So this is the correct answer. Any questions? Now, obviously, there's 30-something of us here thinking about these, which numbers would work, and we got an answer with my hint. It's not the best situation to guess and check on a quiz or test. So there's many different methods that we're going to learn today on solving systems, which you should have already learned in Algebra 1. But since we were talking about that the graph of a line represents all the answers, check this out. Let's say I took this top equation. I want to do it in blue. If I were to set in slope-intercept form, subtract x, rewrite it, y equals negative x plus 4, this blue equation would cross the y-axis at 4, and it would go down 1 over 1, down 1 over 1, and this would be my line right here. You don't have to do this, just watch. Okay? And now, if I graph my other one, let's say in green, I would have to subtract 2x to get it in y equals mx plus b, but it would still be negative y equals negative 2x minus 7. So I'd have to multiply everything by negative 1 to make it my y equals mx plus b equation, y equals 2x plus 7. Are you with me? So this would cross at 7, and I would go up 2 over 1. Now I'd have to use the pattern backwards to extend it in the other direction. And that blue one, let's extend it as well, using the backwards pattern of up 1 over 1 in the other direction. So we have this green line that represents all the answers of my bottom equation. And I have the blue line that represents all the answers of the top equation. So if I'm looking for that one common answer, what's that answer going to be? Oh, where they cross. Where they cross, exactly. All the answers are the green, all the answers are the blue. I'm looking for that one single answer that works for both. So that's going to be where they cross. What's that location? It's negative 1, 5. So the answer is negative 1, 5 to this entire system. So instead of guessing and checking, graphing is great. Is it the best method? Heck no. But it's definitely great. And in the real world, you use solving systems by graphing a lot more than anything else, like for presentations and whatnot. Anyway. Let's move on. Don't copy this down. I'll tell you what to copy down in a bit. There are two types of systems, those that have answers and those that don't have answers. Okay? A consistent system always has at least one answer. An inconsistent system has no solution. it's best to get the visual of this by looking at the wall right there. There are two types of systems. Check it out. Consistent and inconsistent. All right, so what did consistent mean? If somebody's consistently bothering you, what happens? Every day, right? So these kind of systems always have an answer. Now, it might be one single answer because they cross, or it might be an infinite amount of answers because when you graph it, one line lands right on top of the other line, which means that they share an infinite amount of answers. You see, when you're solving a system, you're really looking for that point of intersection, that one single answer that they have in common. But what if you graphed it and they have all these points in common? Either way, we call those consistent systems. Now, what does that mean? It has one answer or an infinite amount of answers. Those are consistent. They always have an answer. Inconsistent, they never have an answer. They have no answers. They have no solution. They are parallel. What does that mean? They do not cross. So when you say, oh, this red line represents all my answers of my red equation, this green line represents all the answers of my green equation, where's my single answer that they share? Well, they don't cross, so they don't share anything. So right there you would say no solution. But if they ask you to classify it, that's where you say inconsistent. So we're going to be solving systems, and we're also going to be classifying. Once again, systems that have answers, they're called consistent. Systems that don't have answers, those are called inconsistent. Now, of those that do have answers, you might end up with one answer, or you might end up with an infinite amount of answers. How do we classify those? Well, if it's consistent with one answer, that's what we say independent. Kind of like if you're financially independent, you're on your own. You're surviving with your own paycheck. If you're consistently dependent, if you're financially dependent, it's like if your parents are carrying your weight. They're paying for everything. And that makes sense right here with the graph. One line lands right on top of the other line. And those have infinite amount of answers. So do me a favor right now in your notes. Let's write down, and you could even draw it exactly like this. On the same page, sure. So just put notes and put consistent systems. And then over here to the side, put inconsistent systems. And then write down their description. Consistent systems have one answer or infinite answers. Inconsistent systems have no answers. They do not cross. They're parallel. There's no solution. And go ahead and draw an example. Just sketch an example of the inconsistent system. And then down here, attached to the consistent, we have these two types of consistent. We have the consistent independent, and we have the consistent dependent. Those are the two types. Consistent independent means one single answer. Consistent dependent means they're right on top of each other. They have an infinite amount of answers. Okay, so if you're not done copying these notes, please watch the video later, hit pause, and copy it later, right? So again, you were supposed to copy down the consistent systems. There's two types. There's consistent independent, that means one answer. Consistent dependent, they're right on top of each other. They have an infinite amount of points in common, infinite answers, infinitely many solutions. And there's inconsistent systems. That means that they have no answers. They're parallel. They do not cross. Now, we're going to use these vocab words when we classify. Now, there's a big difference in classifying and solving. Okay? Classifying is giving the system a name. Solving is actually looking for that answer. So, for example, if I were to have a system and I graphed my red line, my green line, and I found that this was my point of intersection, the coordinate -3, -3, that's my solution. If they ask me to solve, you're going to say, oh, my answer is -3, -3. But if they ask you to classify it, that's when you say, oh, that's a consistent, independent system. Make sense? What if they asked me to solve this one and I graphed them and I ended up with the same line? What would my answer be? Right there, I would say infinitely many solutions. I would say IMS if you want for an abbreviation. IMS, infinitely many solutions. That's if they ask you to solve, right? That's your answer, IMS, infinitely many solutions. But if they asked you to classify it, then you say, oh, that's a consistent, dependent system. So classifying is different than solving. Classifying is giving it a name. Solving is getting the answers. And in this case, there's an infinite amount of answers. That's why we say infinitely many solutions. Now, over here on the inconsistent one, if I were solving a system and I graph to find the answer, I'm trying to find that point of intersection. Where do they cross? Nowhere. So if they told me solve it, what would my answer be? No solution. So this is my actual answer is no solution, right? The answer. But if they say classify, that's when you say, oh, it's inconsistent. Okay, so there's a big difference in classifying and solving. Okay, solving is finding the answer. There is no answer. You say no solution. Classifying, they don't cross. It's inconsistent. All right, so I hope this video helps. Let's jump to the practice.